Okay, welcome back to day 4 in geometry of Unit 11, 2D and 3D shapes. So we went through just the basic, how do you find the volume of all the different shapes, just reviewing those and then adding spheres today. Then we did a composite figure combining the two shapes together. And so this is another way about combining shapes. It says, what is the volume of the space between the sphere and the cylinder? So instead of adding the two shapes together to find the total, what we're going to need to do is subtract the shapes to find out how much room is around the sphere inside the cylinder. So I'm going to take the volume of the cylinder, and I'm going to subtract the volume of the sphere. Again, I'm just writing these out in words, the directions of what I'm doing, so you have an idea what all these numbers mean when I go to start writing them down. So volume of the cylinder is pi r squared h. So pi times the radius squared, which would be 12 squared. But then we have to figure out, what do we think the height of the cylinder is? Now this sphere touches the cylinder on all sides. So if I know it's 12 to the top and 12 to the bottom, the height of this is going to be 24 centimeters. Okay, so let's figure out that number. That comes out to about, let's say 10,857.3 or 0.34 minus, let's do the volume of the sphere. The sphere formula is 4/3 pi r cubed. So the radius was 12 to the third power. That's what we're looking for. That is about 7,238.2 or 0.23. And now I'm going to subtract that to figure out how much volume is on the outside of the sphere but still inside the cylinder. It looks like we come out to about 3,619.1. This would be in centimeters cubed. So that's the remaining volume we would have to fill up with some kind of foam or something to support that, or that would be the air amount that would be around that sphere. The rest of these are word problems. Some of them are working backwards. So a plane intersects the center of a sphere with a volume of about 523.599. What is the area of the cross section? So the volume of the sphere is this big number here. So that is our sphere volume. We want to find the area of the cross section. When you intersect a sphere, the cross section will be a circle. But I need to find the radius of a circle to find the area of a circle. So if we work backwards, a sphere is 4/3 pi r cubed equals 523.599. That is our volume formula. To work backwards, we can do this in a couple different steps. You can divide the 4/3 to the other side if you want to first. You can try dividing the whole thing. If you have a parenthesis button on your calculator and you can divide that big number and you can put in 4/3 pi into a parenthesis, then divide by it all at the same time, like 523.599 divided by parentheses 4/3 pi. If you cannot do that all at one time with a parenthesis button on your calculator, do them individually. If we did that, this comes out to r cubed. Just double check my math here. 523.599 divided by parentheses 4/3 pi. I come out to about 125. One of the other days we had to do this, I think, or where we have to work backwards. Like if r squared equals something, we'd have to square root. In this case, we have an r cubed. So you're gonna look for a button on your calculator that looks like this, where you're gonna type in a 3 to let it know you want the cubed root of 125. So most of us will have to probably type 3, that button, and then 125, enter. Some of you guys that might have the Casios, you might have to type it in different, or if you're using a Google calculator or a iPad calculator, the cubed root of 125 is 5. So 5 inches is our radius. Now that we have the radius, we can find the area of a circle. The area of the circle equals pi r squared. So this one would be pi times 5 squared, which would be 25 pi, or let's round to the nearest tenth, so I'll say 78.5. Because we're doing area, I'm going to say it's centimeters squared instead of cubed. So this one had to work backwards to find the radius and then use the circle formula to fill that out. All right, how about you guys try the next one? You don't have to find area, but you do still have a volume of a sphere or a ball. You will have to work backwards to find the radius, and then you will just double it to find the diameter. Our sphere formula is 4/3 pi r cubed equals 1150.35. So on this one, if I don't have that parenthesis button, I'm just going to work through how could I do it if I don't have a parenthesis button. Couple different ways. You could start by timesing the 3 to the other side if I don't have that parenthesis and fraction buttons. To get rid of the 3 on the other side, you times the 3 to the other side. So I'm just going to do this one in a little slower steps because some of us don't have those buttons to make it easy. So then I would have 4 pi r cubed equals 345 1.05. Okay. If that's the case, I got rid of that fraction, then I would divide by the 4. So then I'd have pi r cubed. Again, I'm just kind of doing these out. If I don't have that fraction button, how could I do this individually without that? And then your next step would be to divide by the pi. I get r cubed equals 274. I know we could just say 6258. We could round it to there, or you could even just round it to 0.6. So the last step to get rid of, I did each one of those individually instead if I didn't have this nice little parentheses and divide by the 4/3 pi. So now I need to cube root that number. That means you hit the 3 and the button that looks like that. Some of you have a cubed root, some of you might have to use the one with the little X there. So you know you have to put the 3 first. Let me type that in. So it looks like the radius is roughly 6.5 and it wants to know the diameter. So for this one, my diameter, if you times that by 2, 6.5 times 2 is 13. So that would be my final answer. It says round to the nearest tenth, but this one it came out even, so I didn't have to. All right, a lot of working backwards. Up at the top of this page, we did some subtracting when I had a sphere inside of a cylinder. This particular one, I have a plastic pipe that's 300 centimeters long. It has an outside diameter of 30 centimeters and an inside diameter of 24 centimeters. The density of plastic is 4.5 grams per centimeter cubed. What is the mass of the pipe? So, in order to find volume, when we're dealing with mass and density, we need to subtract to figure out the volume of this shape first, and then we can multiply by the amount of density. If the density is 4.5, multiply that at the end. So I'm going to say we're going to do the outside first. The volume of the outside would be pi times, we have a diameter of 30, so I'm going to say that's a radius of 15 squared, pi r squared times 300 would be our length, okay? Then I'm going to subtract minus the inside. So this one has a diameter of 24, so do pi times 12 squared times 300. Now I could show you some ways to kind of work backwards from distributing and solve this, maybe a little easier, but most of us are probably going to use our calculators at this point anyways. So you can do these individually or you can do them together. If you do them individually, this is 21,205. Oops, still was wrong on that. It's even bigger. 212,057.5 minus, if I did this one individually, this one's 135,716.8. Okay, if I subtract those two numbers, come out to 76,340.7, and that would be centimeters cubed. So the last thing, once you figure out how much the actual pipe is made up of, plastic is 4.5 grams per centimeter. So you're going to take your answer times 4.5. And our final answer is a really large number. So 343,533.15 grams. All right, last one. It says a tennis ball with a diameter of 3 inches is placed in a cubic box with sides 5 inches long. So this is very similar to the one above. It says how many cubic inches of packing foam will be needed. So it's just another additional practice of this one where we have the ball inside the cylinder. Same thing here, it says we have a tennis ball with a diameter of 3 inches. So it has a radius of 3. It's placed in a cubic box that is 5 by 5. How many cubic inches of packing do we need? So if we do the sphere, the ball first, we have 4/3 pi r cubed. Oops, let me, instead of putting just the r cubed, let's go ahead and say the diameter was 3. So over here, diameter is 3, the radius will be 1.5. So we'll find the volume of the tennis ball first. It's about 14.1 for the tennis ball, and that would be inches inches cubed, and then the box, a cube is just length times width times height. In this case, it's 5 times 5 times 5, since they're all the same on every side, which is 125. How many cubic inches of foam will be needed to fill the rest of the box? So if I take 125 minus the volume, 14.1, seems like a lot of packing. 110.9 inches cubed. It says round to the nearest tenth. So the amount of cubic packing inches would be 110.9.